So guys, in this project just we are going to do the language classification model. So the some language, mainly I have used here the three kinds of language. First one is English, second is that African one, and third is I think Spanish or something. So there are three kinds of language there have. So if based on the three kinds of some language data, we will just want to build a machine learning model. Okay, and in the descriptions I will give that the description of the data sets, so you can download from there. So just see the agenda of today's project first. So first of all we have to import the necessary modules and the packages that we need. After that we will creating that the features. So the thing that first we have to understand why we need to create the set of features, because guys you will see the data sets that we have used here, it's a simple text data, there have no any features. But the thing that to apply the machine learning model, we need to build the features, set of features. So for that reasons, we have to first build the set of features to train the ML model. So we will see how to build the features kind of thing. We will learn then that thing here, how to apply the text data to build the set of features. We will learn it. So after that, we will have to see that the features that we have built is how much correlated to each other. After seeing that data, if there have no much correlation, there's so much relations, then we have to reduce that correlations, because you can guys in the theory part we have learned that the correlated data have not give some much informations of that particular model. So for that reasons we have to reduce that correlations. We'll see also here how to reduce the correlations also, and after reduction the correlations we apply the ML model. Okay, and after as always we have to test the accuracies, and that's for all 2 days project. That's, I think you will understand what is the agenda. Now let's see what does the data sets look like that. So this is the language data sets that we are going to use here. Just see a look that how it's look like. As you can see here, it's that in that data sets we have the text data, that's are the text data, and these are the language data. There are mainly three types of that. I already told you that English, Africans, and one also here, and neither, I think is Netherlands. Okay, these are the mainly three types of language that we are going to use here. Now let's open the first the Jupyter Notebook. Save it. I am already make that folder, and let's make a Jupyter Notebook on that particular folder. Let's open it. Yes, so I have opened that one. Now let's go to that particular folder. That's our folder, ML project, and it's our 14th one. Okay, and that's the folder. So in that folder, let's build that Jupyter Notebook. So first let's rename it. Let's copy the first that name. Okay, so first thing what you have to do, you have to require that importing the necessary modules and packages. Let's import it. Okay, let's import that primary one. After when we need it, we will import that more one. So first import that necessary one, that is here we need that numpy, math, pandas, collections, such kind of primary module we need here. So let's import one by one. First we have import that numpy. After that we will import that math, and also one thing we need that pandas also we need. Okay, sorry for that disturbance. So, and also for handling the dictionaries and counters, also one library we need here. I think just explore yourselves, guys. So here we have needed collections. Okay, and for find the permutation, because guys, we see it's our text data, we have to build some various kind of permutation to creating our features. So for that reasons also one library we require here, the iteration tool. So for finding the for find the various kind of permutation, to input permutation. Okay, so till now we need that one. So after when we require, we will input. Why it's line 5. Permutations. Spelling are okay. Let's see it. Why it's error? Why this module? So let's install it. Okay, guys, not import. It will be from. Sorry, guys. Okay, now it's okay. Let's run it. Yes, just a minute. Yes. So till now we need that one. After we need it, so let's see that. Let's now load that data first. So data frame will be in pandas. We need to import the data. So guys, you can see it's already a CSV file. Data set name language. It's language, I think. Just a minute. Yes. Okay, let's see the data first. Yes guys, you can see the if there have any missing value. Yes guys, you can see there have lots of missing value in the text column. So for that reasons we have to drop that null value for the days row. So first let's drop that one. Yes, now we have removed all the null values for the is row. Now let's see convert. Now let's convert the column text. In that column text from the let's see the first what are the data look like, what are the info of the data. Yes guys, you can see is data is our object type data. You can see let's first that convert the text data from object to a text, because guys it's a text data and we need to convert that text into as a such like a string data. Okay, let's convert it first. Okay, to convert it that column we need to that text will be our df text and we have to convert it as type. But we need the string. Okay, now let's run it. Yes, what happened? text h type string, right? So that data type is string here. Yes. Okay, no problem. Why it's not seen, I'm not, and error is also not seen here. So no problem. When we need it, we will see. Let's go further. When we face some error, then we will reduce that error. Why it's not happening actually? Just to for our purpose, we have converted that thing. But why not it's so error, and why these things data type is not showing that string type? So let's see. Let's go further. Then let's move ahead. Then we will see. And also we have to convert that language column. Yes, this column means this language column also in a string type. Let's convert again itself. H type. Okay, spelling good. Now if I again see that one, what happened is it's objective, no problem. We'll see that thing further if we faced some problem. But so that's to converting the data set. Now we have to go to our next step, that is we have to create the set of features. We need to create it. Okay, let's create it first. Let's make it as heading. Let's run it. Yes. Now so first let's make a list of that common punctuations that we have found in our text dataset. Okay, let's see what kind of punctuations they are having in our text dataset. You can see, guys, if you see, that's one dash and slash, but slash also comma, this type of. So let's remove that one thing first. Let's make a list of that such kind of permutations, such kind of punctuations. So let's call it pun. Okay, no problem. Pun, insert pun. What are the list of the punctuations here? So first we have taken here the question mark, then we have to taken that dash, then we have to taken that dot, then a comma, then also we need backslash, then again also we need the semicolon, sorry, semicolon, then forward slash, then again we need forward slash, exclamatory sign also we need. Guys, you can see here one thing, if I remove that one, so that sense will be totally different. So we have not taken that such kind of punctuations. Okay, because of the other reasons, guys. If I remove that, suppose vouchers, if we remove that voucher stock and voucher stock, totally different meaning. If I remove that one, so meanings has totally changed. If I, so for that reason I am not remove that one. Okay, and percentage also we need it here. So that's our list of the punctuations that we created. If we needed that one, then we will create more. Again, why that's type of why this type of thing occurred here? Let's see why these things is not happen. I think this symbol have to see, so let's remove it. Then let's run. Then this here also, okay, here I have to take that single inverted comma. Okay, equal while string is direct. Why, let's see why one thing also you have to notice here, guys. Why exclamatory, why this semicolon is not taking here. You have to see about that. Just make a space. Okay, let's see it. Okay, here also you need to single inverted comma. If I run it, so guys, you can see it's the black color, but after that its color has changed. So I think there have some mistake I have done. Okay, let's remove it. So here in that, okay, till now okay, but from here we have faced that mistake. So let's put one comma. Okay, now it's okay. Let's run it. Yes, guys, you can see. So color is the main thing, guys. One thing again, I am want to showing you that mistake that I have mistake, guys. You can see this comma, that color has been black, but after that the color, that the particular comma color has been changed because of in that line we have some mistake. So to remove that one, we have to again that comma. After that all the things the color has been okay. So that's the main reason. Okay, I think you will understand the error why I have doing that particular error. Now let's define that vowel. What do we need? Sorry, vowel. Okay, UW. Okay, in short, okay. Now let's define it. Now one is we A, E, I, O, U. That's our vowel. It's okay. Now let's make all that features in a single cell. Okay. Now after that we have to define the list of double consecutive vowels. Sorry, on double consecutive vowels means A, E, I, O, U. That's kind of have to define. Okay, we will see. Also these things also we sometimes we need this type of thing. Okay, in short I have defined it. A, E, I, O, U. Okay, now we have to join all the things. Okay, first let's join it. Now let's join it because we need to join, because guys, so that consecutive vowel that we have used here, so typically that's things to characteristics that the African language or neither region language. So for classification these type of things we need to type of. Okay, so just study on using Google or YouTube, you can understand. So what criteria they have on that African language, this kind of. So for that reason it's very simple, nothing else. So I have named it consecutive double vowel, and now it's the consecutive vowel. So for count, we have to join this. In we have to take that library permutation, and we have to join this set. And suppose take I have taken here the 2. Okay, if I have taken 2, just paste that shifter, then you will understand. Permutation iterable, yes, range 3 2 means 0, 1, 1, 2, all that type of permutation you can take that 3. So 3 order permutation we can make. So here just I am making the permutations only 2. Okay guys, I think you will understand. It's just I have taken pairwise permutations, nothing else. Okay, just run it. So if you see that consecutive vowels, then you will understand that one. Yes guys, I think you will understand. Such type of its join. Yeah, it's a double, but it is that permutation type. For that reasons we have joined this one. Okay, and for one language, that is D. For this language, I think its spelling is Dutched, D-U-T-C-H. Okay, I am not pronouncing accurately, just sorry for that. So its combination value will be, I have taken here IJ. Yes, that's all. And these things we need to find that features vector, creating that features. That helps us to creating the features. Let's create that feature first. Okay, let's create it. So first let's the features that word count we need. Let's make a column. We call it word count. Then we have to take that particular text column, and here we have to apply that. We have to split that its text. Just see it, guys. We have to split that its text, and we have to put that space into that word count. Okay, column, word count column. Sorry for that. So just here, how much word we have? 2 words. Here, how much word? I think 1, 2, 3, 4, 5, 6, 7, 7. So such like that. So we have to apply the splitting. Okay, apply, and for splitting we have to map that lambda function. And length of that split, x will be our text data. Okay, that's all. Let's run it. Okay, now if you see that our data frame, then you will understand. So let's see it. As you can see, here we have 5 words. Here we have 3 words, here we have 2 words, such like that. It's an important features we need. Okay, now let's create that second features. So second features that we have to create that character count, how much character they have in a particular text. Okay, means that here we have count that word count. Now we have to create that character, it's word count, character count. Let's create that character count. character spelling ch. Okay, what happened, guys? So sorry for that. Sorry. So sorry for that technical mistake. DF. So it will be DF and text column. Similarly, you have to apply that this function gets copied. And instead of here, we have to same thing. Just you have to, instead of split, we have to use that replace word here. Okay, just here I have to take the length, but here I have to take in the character. Simple thing. Dot replace, and we have to split it based on this. Okay, that's all. Let's see. Okay, now let's run it. As you can see here, that's simple. Yes, so what's count 5? How much character we have? 26. How much character we have? 20. Just see, guys, here you can see 1 2 3 4 5 6 and 1, total 9 character we have here. Okay, I think you will understand these two features. First, the primary features we need here, word count and character count. Now let's that's the features we need. We have to find that word density. Okay, word density. Let's create a column. Density. Same thing also we need it here. So for that reasons we have to word for calculating that density, we need that word count, and we have to divide it this thing on the particular graph. Let's how much word count we have and how much character we have on the particular data set, on the particular text sentence, or you can think like let's take plus 1 here. Let's see it. Yes, you can see the density value you can got from here. Okay, that's the simple formula. Now guys, let's compute that punctuation count. Let's compute the punctuation. Let's compute that punctuation count. I will compute it. This column we need here, text column. Actually guys, you can see that word density is totally related on that one. If we find that correlations, we can find that word density totally correlated with word count and character count. So when we find that correlation, then we will understand that thing. Okay, now let's be specific. Okay, when we compute that step, then we will understand. Now let's be specific. Yeah, the dot here also we have to take mapping that one. Apply that lambda x, and here we need that a length. So here length, and we have to pass that a, and a will be in, we have to take that forward, a will be in punctuation that we have defined. So for a in x, if condition we have to use, if a in, but a in that lambda will be x a, for a will be in x, and if a will be in what, we will be in punctuation p1. Okay, that in that punctuation that we have defined. Now let's see, run it. What happened, guys? Why it's error? Punc. Okay, yes, again error. punc, what's pun? Sorry, it's pun. Yes guys, now you can see. So here guys, you can see here how much punctuations we have. Nothing here, and 2 punctuations, this one, here also 1 punctuations, 1. That's all. I think you will understand that features. Okay, now our next feature is vowel character count. Okay, now let's see, let's see it. I will compute it. Let's compute that vowel character count. So vowel character count. Let's copy that one. That things we are all are okay. Okay, let's close it. Now from here we have to apply the length function, and on that functions we have to compute. Length means we have to compute the number of vowel we have. So same things, a for a will be in, just copy it, the same thing. Instead of punctuations we have to call that vowel set that we have already built is in okay, vowel. This one we have to vowel is in simple vowel. Okay, let's run it. Let's see the features. So instead of v, let's compute that vowel vow. Okay. So that we have to remove we'll see drop. Okay, let's run it. Okay, let's run from the previous one. Okay, now if you see that you understand that thing. Yes. Punctuation count, vowel count, vowel here you can understand vowel is 9, number of vowel is 4. That's one important features we need here. Okay guys, I think you'll understand. Now we have to compute that features. Let's compute that v, how much v we have in a single word. Let's compute the v character count. V and W. That's an important features in that, and African language, I think. Yeah, and just see, just search it on Google, then you will understand what are the features in important. Let's I'm trying to build that type of features. Lambda x and same thing length. Okay, a for a will be in where x, if x is in, you have to apply that x conditions. If that equals to the word v. I think yes, guys. Let's close it. Yes, guys. Now let's run it. What happened? Str case fault. Sorry, case fault. Yes. Now let's see. V character count, guys. You can see here only one V there have. Here 3 V's there have. That's all. Now similarly, let's count the W character. Yes, you can see these are the W's they are having our text purpose. Now let's compute the IJ character count. How much IJ they are having that character. Okay, let's compute it. So let's calculate that IJth character count. The same thing we need up to here. After that we have to change the function. Let's close the bracket first. Okay, then we need this any. Suppose let's have taken here AB combination will be in where A for what for AB that I have taken, that will be in where that value we have list that we have made, and for which for A will be in split, we have to split that one. So this A will be come from here, the splitting. Start split. Okay, that function we have to apply on that example, this one. Okay, anything is pause this thing. Okay, that's all. Let's run it. Yes, let's see the data set. Yes guys, you can see ijth character count. If there have some ij, then it is counted here. Okay, till now it's 000. I think there have some. Okay, now the next features is that we are going to count now. So that double consecutive number of double vowel that we have, that we are going to count. So now we are going to count that this feature dl. So okay, these features now are going to count. So for that we have to copy that up to these things we have to take. Now after that we have to change this one. So same here, same things also needed here. Let's copy it. Some little bit change we have to do. So it will be a for ab in that will be that double vowel. Okay, let's compute it. So here guys, you can see here two vowel counts we have aa. Okay, such light. So another, let's copy it. Now we have to that consecutive vowel. Now we have to consecutive vowel. Interesting number of consecutive vowel counts. Consecutive. Same thing, instead of double one we have to use that one. That's it. Okay, let's run it. Now let's see the data set. Yes, consecutive vowel count, you can see here 2, here 1. So here 1, for which it is shown it's 1. For IO, these two are the vowel. Okay, now let's another type of number of vowels already we have computed. Yes, number of vowel, how much vowel we have, vowel character count we have computed it already. Now let's just a minute guys, just for better let's cut it. Paste it here. Okay, now let's compute the vowel character density. It's also an important feature, vowel character density. So to compute that vowel character density, we need the number of vowel. It's totally dependent on this number, how much number of vowel we have, divided by. So divided by number of word count that we have, we need here. word count, how much word we have. That's all. Let's run it. Now let's see the data set. Yes, this is the vowel density, the vowel count. Now let's compute that how much capital letter we have in a text. Let's compute it. How much capitals? So the text column we need here. Apply lambda also we need here, and to just close it. X will be sum one if for that approach for that C is in X that I have taken if when if the C is what? I super. Okay, that's all. Let's run it. Now let's see that letters. Here guys, you can see capitals 2 we have. It's capitals 2. Similarly 1, 2, 2. That's here. So I think you'll understand. So the next feature that we are going to compute, that capitals length versus length. Okay, how much capitals we have and how much length. So that means the capital length, you can think. Capital letter lengths that we are going to compute here. Apply lambda functions we need was X, and for computing that length, so here we have to not sum, we have to take that float function, float, and here we need that capital row. And we have to divide it. I have to first find that float value. After that we have to divide it into the float value of which one? Row, which respective which column. We have to length, character count, not word count, because we have only restricted capital one. So how much capital? So capital, it will be better language if we write it capital versus the character count. Character. Capital versus character. Okay, every taken that one extra. Okay, so here axis will be 1. Sorry. Yes, so let's run it. So if you don't understand what is axis 0 to 1 means, just search it on, just zip it, space shift tab, then you will understand. Axis in default it's 0, but I am taken here that 1 means what? Means is the object passed to the functions a series object whose index is either database index in 0 or data frame columns axis. So I have taken this one. Okay, very simple, data frame columns axis. Okay, I have done that mistake. Spelling of that axis, it will be AXES. AX. What happened? Lambda got an unexpected keyword axis. Why? Just let's see. I just analyze the error. We have applied that lambda value and lambda x. Okay. Sorry guys, it will be row, not x. And the rest of the thing, I think it's okay. Now let's run. Yes. But let's see it. Now let's see the function again. It's capital A. Okay, let's write that capital A. Capital A, what happened? It is the argument I have passed axis. DF. Okay, no problem. Let's see what's the error. Lambda got an unexpected keyword argument axis. Unexpected arguments 0. Same error. Guys, let's look in more depthly. Just try to analyze yourself. So guys, we don't need such type of functions, just direct apply it. Just I am trying to do it in different way, but not need. Just do it in that way. So we need here this capital column divided by, here we need here this character count column. That's all. Let's run it. Yes, you can see. Now we have to next, in the next category that we have to compute that exclamation marks. How much exclamation marks count we have. So now our data frame is df. Now we want to make that exclamation. we want to make this count simple as count this. Also just copy that one, just some length function we need here. Apply lambda will be in x and don't need count. Exclamation sign. Okay, that's all. Let's run it. Yes guys, you can see if there have any exclamation sign we can count it in our features. Thus next feature, next compute that how much question marks there have. Same thing, let's paste here. Yes, now next feature, let's compute that number of how much number of punctuations that we have. Punctuation count, I have computed the punctuation. Yes, I have already computed that punctuations. Now the next features that we are to calculate that number of unique words. So let's compute that unique words. So we have to take the data frame, fix data frame, then same function we have to apply. Compute the length, and now we have to convert that set into that set, and w for w will be in what x dot split. Okay, that's all. Let's see it. Yes guys, you can see unique words there have these are the unique words 5 2. Just see that one, or row, just see it. Yes, is it 2? That's simple. Now let's compute that number of unique word. I think you'll understand how we computed the unique word. Now let's compute the number of repeated word. Now let's copy this. Till now it's okay. Let's close it first. So number of repeated word will be that first length we want to count. We have to make a w and use that for loop. W will be in what? W will be in this one, this, So w will be where? W will be in your collection. Collection means the collections that the file that the we have imported for different counters. Collections to make it as counter and to make a split. Have to split this. Now let's close. Okay, now I have to that if conditions we have to use. If this w that the length we have computed, if this length will be greater than 1. Now let's run it. Not supported between instances of str and int. Why? W is the simple collection counter and we have to make that split. After splitting, sorry, we have to use it. After split and the split if this w greater than 1, then we will split this one. Okay guys, sorry for that. We have to split this one in which basis? Sorry, we have to take its values and then we have to compare. After that we have to, if split we have to take that string, but it's not comparable with 1, so for that sense we have to take its values. So now it's okay. Now let's see the data set. Yes guys, you can see the repeated word here. One repeated word we have. Just see that text. Enable maintenance leaves in there. This. There have dot means there have some word also. For that reasons there have 2 words only repeated words one. Okay, I think you'll understand that features. Now let's make our that the how much word we have and how much unique word we have. Let's compute that one. So word versus unique word. Sorry. So here we have the number of unique words. How much we have divided by number of word count that we have. Okay. Now let's see. Yes, all are unique words. Here only not. So that's one kind of features. Now after finding that correlations you will understand, and one also features we record here. That's that encoded value that we needed here, encoded. Let's see how we'll encode it, how we'll find that encoded value. First let's compute it as none. Let's take it as none value. So after that, after using the forward loop, we have to fill that null value. Let's see. Okay, so for I it will be in range. Where range? It's that length in our data frame. If you try to find the length, what is our length of the data frame, then you will understand. Length means I am talking about the number of rows, how much we have. That's the number of rows we have. So that's simple guys. So length and try, we have to use the try function. you try print df and it's find the text, you have to use the text column, and here we have to that will be in this one, this number of row, and we have to use that encode function, encode, and which basis we are going to encoding, encoding spelling, yes, UTF-8, it's most commonly used. These encoder are most commonly used, and we have to decode it based on that SI value. Because why actually I am showing you why I have required here to encode that thing. So if you see the data set, guys, then you will understand that thing. Why actually we just you can see this type of thing. So for the artisans we have to encode it, and in most commonly used that encoder is equals to UTF-8. Okay. So that's the encoder that we record here first. Now except if that they have not some error. So for that reasons, if there have some regions, we have not avoid that thing. If we paste that error, then the data text if that gives error this error, then we have the make that encoder column. This column will be now filled by this value. So not equal. It's to 0. Okay, means that just I am again repeating that thing. First, we have to try that encoder. If that error occurred, then we have fill 0. Otherwise, we have to fill 1. Okay, if we have done encoding, then we have to fill it. If the is yes, suppose guys, just see the data set. Suppose it's here, we have required the encoder. So for that reasons, we have filled here 1. Otherwise, if there have no error, then here also we have needed encoder. So for here also we needed encoder. So for that reasons, we have to paste the error. Otherwise, 1, otherwise we have to paste 0. That's simple. Otherwise else it will be 1. That's all. So let's run it. Now let's see that data set. Let's have some wirings. Let's avoid it. Now let's see the data set. Yes guys, now if you see that encoder, yes guys, you can see. Yes, here I have some error. You see that there have not some no error. Here also there have some error. So let if you here also okay, I think you will understand. So now let's group that function. Now that the features that we have made based on the text column, the text based on this text column, the features that we have made, and these features are helps us to train our machine learning model. Now let's see that target column. This language is our target column. So now let's see that how much statistical information they are having that. So first let's apply the group by how much data we have, how much language we have. Group by, and based on the language, yes, let's compute that means, and we are trying to see it as table. Let's see it. As you can see, there have only 3 languages we have: Afrikaans, English, and Netherlands. Okay, Afrikaans, English, and Netherlands. Okay, how much word count we have, how much character count, word density, that means these features that we have computed, this statistic, this mean value. Actually, I am showing you what are the mean values of the word count, English, and these are the means that African. From here you can see the African languages are the so much long type of characters. It's obviously its character count must be also long. Its word density is also high. That's the simple basic informations. If you see, guys, number of vowels, vowel density, so most of the vowels are occurred in that one, Netherlands. And capital, most of the capital also in that African. Unique words are also most of the times are occurs in that African. And repeated word also in African language. Okay, means that just simple idea we could generalist here. So if they have African language, then that word, the length of that word is so much large. So now let's find that correlation, then you will understand more details. So let's compute it. Let's compute that correlations, and I am using here that the Pearson correlation here. Already we have learned. So now if that degree of that correlations between the characteristics, let's see it. And here we have to use that method equals to Pearson. I'm not going to discuss again what is the Pearson correlation. Just go to the theory part, then you will understand. I'm already discussed that thing. Yes, guys, you can see these are the correlations. So it will better just see that PR plot. So Seaborn library we have to install. I'm not installed the Seaborn library. Let's see, guys. So no, sorry for that. Let's install that Seaborn. Wait little bit. Because guys, you can see here how much features we have created. So to find the correlations, and after that you have to plotting So just 30. If I think how much correlations, how much column we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So for 20, 20 into 20. So 20 into 20 is 400 pair plots. It will plot it. So it will take some time. Just be patient. Just be seated relaxedly and enjoy the background music. Okay. Okay, I think it will at the end of the stage. What happened till now? It's processed. Actually, guys, it needs also a system configuration. If you have so much system configurations, then it need less amount of time. But be patient, guys. Yes, guys, now it's occurred. Let's see. You can see these are the pair plots. So it's also correlated. These are also correlated. These things are correlated also. So here, what is the maximum correlation value? Guys, I think this 96% maximum correlation value. As you can see from here, means from this picture you will understand. These are the correlated value. 96%. And here also some correlated, more correlated value. 71%. 66, 98%. 98% correlation value. So I'm not taking the main diagonal elements. I'm just, because diagonal element always one, you can see always one diagonal element. So maximum correlated value we needed here, that 98%. So we don't need such kind of correlated columns. So for that reasons we have to avoid. So now let's remove that. Let's remove that, reduce that correlated value. Okay, and mainly we have reduced that correlated value on the training data sets. That is the main factor, not the test data sets. Okay, so for the data sets, first we have to split the data set. So let's split the data set, then we have to reduce that correlations value from the training data set. So first job that we have to do, we have to splitting the data to remove that correlated columns from that training data. Let's split it. So let's split the data first. So first what will be the features vector, features column. So our features column will be so I have to take that as a list and data frame columns and from where, from that, these are the columns that we have to take. So here these are our features vector that we have to take, means from 0, 1, 2 to rest, 2 to all. So features columns 2 to all. That's all. That's our features. So if you see the features, so the features column. Yes, these are the features column that we have taken here, and we have taken as a least value. Now let's split it. So our x will be in the training set that we have to use the x train data frame, and on the data frame we have to pass that list, this list. This will be our features. So let's see the x, what it's look like. Yes, these are the features. Now our target column will be that column, it's language column. It's our target column. And all the data frame we need it here. Now let's see closely what is the look like y. Yes, it's the y. Now I have to splitting the data. To splitting the data, we need to import that library trains test splitting, and it's available on the sklearn. Okay, so xtrain, then xtest, then ytrain, then we need ytest. Okay, now let's apply the train test split. So that module we need to call train test split. Train we need this one. Now I have to pass that our x that will be divided into train and test, and then we have to pass y that will be divided into that y test, y train and y test. Now we have to define that test size, how much test data we are taking, and you have to take it as 20% for test data. Let's run it. Okay, because we have to import that module, train test split module, we need to import. I am not importing that thing, so for that reason it's showing that's mistake. Sure. So these modules already we have seen. We have to from sklearn we have to import. From sklearn we have to import from sklearn model selections. These features are available. Okay, let's run it. Yes. Now if you see that shape of that y test, x test, suppose let what happened. Yes, as you can see, so these are the test size 553, number of rows we have taken as a test set. Okay, now let's reduce that. Now let's reduce the that correlations value that are taken. And here you can see, guys, we have taken here the 98% correlations value, maximum correlations. So we have to drop that number of columns to reduce that correlated means that's simple, guys. We have to drop that number of correlated columns. So to dropping that things, PCA we have to apply. In linear algebra we have already learned how to drop that one, PCA, principal component analysis. So let's apply that PCA. In theoretical we have learned, now let's apply it in practically. So to apply the PCA, one thing, guys, you can see here we have the data, that the features that we have, it's not a same standard. And so first that reasons we have to normalize data in the same scale. Okay, in the same scale we have to normalize the data. So for that reasons we have to import that standard scalar library from scalar, and it's also available standard scalar. So first let's import the necessary library to doing that necessary step. Let's import it one by one. So for scaling the data we need first scalar, for model, matrix. So there are lots of things we needed here. So first let's import from scalar. We have to import that. From here we have now pre-processing step, scalar pre-processing. We have to import what? We have to import that standard scalar. Okay, and also we need that PCA. The decompositions we have to import that principal component analysis we needed here also, and one thing, matrices. Okay, till now for reducing that thing, till now it's okay. Now let's make a heading, guys. It will be better for our future. Okay. So first let's scale standard scalar we have apply here. Now we have to fit it, the scale we have to fit. On our data set, which data mainly we have to apply? X-train data. Okay. Now transform it. After transform board that text set. So we have first training that scale, in which now we have to transform the whole data on that X-train and X-test. After fitting that scale, then we have to transform the whole model. Okay, that's all. Now if you see our training data, then you'll understand. Now guys, it's in the same scale, all the okay. Now apply the PCA. So here you can see that correlated value that we have taken here, the 98%. So now let's apply the PCA to reduce that at correlation value, and I am trying to reduce it up to 95%. Correlations are okay. Suppose let's okay PCA, I want to reduce it up to 95%. Okay, now I have to PCA fit it mainly on our training data. Okay, let's fit it. Yes, done. Now let's see how much principal component, how much number of columns we have. First we have seen that it's a 20 columns we have. You can see number of 20 columns we have. Now after applying the PCA, how much features we have, let's see. So how much number of columns we have dropped. Okay, now for that print number of principal component now will be what? So that we have to that convert numerical value into that string value PCA dot n components. Okay, that's all. Let's run it. Yes guys, after dropping it, you can see from 22 now we have reached into the 12 number of 12 columns. After drawing, only 3% correlations we have dropped. For dropping the only 3% correlation, so we have reduced that 8 number of features. So that's simple. Now I think it's okay, 20 number of features, because guys you can see most of that features are dependent from the other 2 or 3 features, because here the features that we have built, you can see that's if I have taken that features as word density is totally dependent on the word count and word character count. Okay, so that's the things. Okay, now let's transform the is data is according to the PCA value. So first let's transform that extrain data. Now our extrain will be, we have to apply that PCA to transform that extrain data. Now xtest, okay, let's run it. Now if you see first that guys, you can see xtest.save is equals to 12. If I see the xtest.12, then you can understand what happened. Let's see from here. Yes, it's now converted into 12 instead of 20. Now we have taken here 12 number of columns. That's the power of PCA, principal component. Only reduce 3% correlations value. Sure, we have reduced that number of features, 8 number of features we have reduced. That gives us so much valuable information. Okay, now let's apply the machine learning algorithm that we have. Now we are in the last step. Sorry, applying the machine learning model, then we have to find the accuracy test. Okay, let's apply it. Let's apply it. So first we have to apply various, mainly I have applied here the decision tree model and the classifications model. Actually we are going to make here multi-class classifications, guys, you can see here. And I have used here the gradient boosted classifier and that random forest classifier. Okay, such kind of classifier we are going to, let's try to apply the various kind of classifier and let's analyze that score that we are going to get here. So let's import the necessary library from Scalon, and we have taken here the ensemble models. We have to import that gradient boosted decision, gradient boosting classifier. Okay, we need classifier, and also we need random forest classifier also we need here. We have to import that decision tree classifier also we need. So let's try to analyze through the various model. Okay, and also for the finding the accuracy score also we need here the matrices, various kind of matrices we need also. For that reasons also import the matrix. Okay, mainly in matrices we need confusion matrix, classification matrix, and accuracy score also we need. So let's import it one by one. From scalar matrices, we import that confusion matrix. So another matrix is we need that classification report. Also we have to generate the report, classification report we also need. Let's another here that ROC value also we need. ROC accuracy score also we need here. And if you want to plot, then you can also take this one. Graph accuracy score also we need. And let's apply the log loss if we something have to prove of. Okay, that's okay. And at the end of that thing I will show you here after making that model how we'll save it onto our library. We'll show you. Now let's train our model one by one. So first we have applied that decision tree classifier. Let's apply it. Let's feed that model onto our data set. And the data we need extrain. X test. Okay, let's run it. CLF. Why happened? It's not defined. DT, sorry, not DF, DT. What happened? Unknown level type. Continuous manifold. Extend, sorry, Y train. It's my bad, guys. It's my bad. Sorry for that. Y train. Now let's start. Yes, we have built our model. Now, guys, one thing you'll show you. We have built our model. Our model is ready. And in our previous video, we have seen how to find the accuracy. Everything we have seen. Now, one thing that we have not, so how to save our model. So to save our model, so one library that we need, we have to import that pickle library. Pickle library. From here, from the pickle file, we can save our model, and we can use it to deploy our machine learning model and end-to-end users. Because at the end of the day, we have to show our model to the end users. End user have no any idea how much features we can apply, how we'll train the model. They at that only they needed the result. Okay, and how will show that results? How will give that model to apply at that on that some deployment thing, or it will be website, it will be application, something that. So for that we have to save that model. So to save that model, we have to import the pickle file. Okay, now let's see how we'll save it. So we have to set, suppose let's see our DT model. I am simple name it decision tree model will be, let's call that file dt model dot pkl. Its extension is pkl. Okay, now with open this model h write wb h file, right? Have to call that one. We have to dump it clf file to our file. That's all. So here we have to import. That's all, guys. Now let's open that pickle file that we have saved. Now if you see our file, sorry, yes, dt model, our that decision tree model we have saved here in that pickle file, and you can see it's 25 KB size. Now let's apply that model onto our parameter, how much score we have, everything. So for the artisans, you have to open it first with open. What's his name that I have taken here? I have taken here that this model, decision tree model. Right now, read it to read it, to read RB H file. Now our decision tree classifier model will be what? Pickle dot float. Okay, I have to apply that file. 120. That's all. Now if we call that decision tree classifier, then you will understand. Yes, it's our model that we have built. Now let's see the predicted score. Why predict? Why predict? Okay, spelling are okay. If I have done some mistake, please be correct yourself. CLF. That's our model. Now I have to apply the predict function. Yes. Here predict functions we want to apply here, and then we set x test. That's all. Let's run it. Now guys, you can see, let's apply that predict. Yes, these are the predicted value. Now let's see how much accuracy we have got from here. Predicted score. Now let's see. That's it. So how much accuracy we got from here? Accuracy score, and there are two things. We have to pass here our original value and y predict. This is our predicted value, and our original value is what? That we have split it from our data set. That is y test. Y is actual target value. Okay, that's all. Let's run. Now let's see the how much accuracy score we got from here. Let's see it. This is not callable. numpy.plot60 is not callable. Accuracy score. Why? Now let's look more closely why this type of errors occurs. So let's see why this type of flow occurs. So accuracy score, we have to take this function accuracy score v, and our value will be y test value, and this value y predict value. Y test, its name are okay. Yes, y test, and the predicted that we have done. Yes, now if we run it, what happened? Just remove this one, just directly print this value. Let's see it again. Let's store it in different name. ACC accuracy. Let's store it in different name. Then let's see its accuracy. What happened? Accuracy score and accuracy numpy plot objects is not callable. Yes, let's run it. Now let's run that accuracy spelling is okay. Yes. Now let's run it. Yes, guys, you can see here. Actually, I am not running that file for that reasons. It's showing that mistake. Sorry for that, my mistake. So it's like you can show that if I use the decision tree model, then our accuracy is 92%. Okay, 93% about. Okay, it's the accuracy score. Now let's see some confusion matrix. Let's see some various type of score. Let's see some that model, confusion matrix model. Let's see it. So here how much label we have, let's define it our label. So let's copy that label that we have here. In that thing we have the 3 labels: African, English and Netherlands. Okay, now these are, sorry, one by one let's paste it. Africans, English and Netherlands. These 3 labels we have needed. And first let's build that confusion matrix. Let's build it. Confusion matrix on our decision tree model. It will be better for confusion matrix for the decision tree model. Confusion matrix, we have already imported that one. Here we need to apply that y test data and y predicted data and the label we need. These 3 needed thing needed here. Y predict is not, sorry, not predict. Why not predict? It would be y predict. It's a show body. That's my mistake. Yes, if you see that confusion matrix, then you will understand. Yes, it's our confusion matrix. I think in theory part we have learned how to. Now let's plot it. This confusion matrix, let's plot it. Confusion matrix plot. It will be more visible, more suitable for us. So let's define that figure. We have to import the matplotlib library figure, and our figure size will be fixed size. Plot dot figure fixed size. It will suppose let's 10 by 10. Plot is not defined, so let's import matplotlib, mainly pyplot we needed here, hplt. Okay, our figure size we have defined. Now let's apply the subplot, because guys you can see here how much we needed here, 3 by 3. So for the additions we have to import that 3 subplots. So subplot, it will be okay. That's all. Now we have just import that. We're just interested to plot that heat map. It will be better for better understanding. Heat map, how to heat map, and our model name, which is our model that we have saved. yes, dt dot clf decision tree classifier. Okay, not sorry guys, it's our confusion matrix that we want to plot this value we needed. Yes, this value for plotting that one, so that value we have needed. Yeah. So it will be true. Okay, if you want to see what is anode, you can see is that the data anode is equals to in general null. We try to understand what is. It's the boolean or for rectangular data sets. It's optional. If true, write the data set value in each cell. If that's simple, we want to write that value. Means for that each cell we want to simply write that value. If you want to do false, then it's no required. It's don't show that any value. Okay, now let's run it. This way you can see it's our plot. It's showing the plot. It's showing the label. And now let's rectify that. Is let's apply that label. Let's apply the label. Y level, what's Y level is our actual rating, and in X level we have that predicted rating. We have the predicted rating. Now let's set that X thick level. Let's run it. Yes, actual is predicted. Now instead of 102, I am going to just write that label value. Okay. Sorry guys, it's label. Yes, you can see it's the African, English, Netherlands. So these are the correlated value. English and English are already correlated. Africans. Sorry, it's a confusion matrix value. Confusion matrix. Sorry guys, it's not a correlated value, it's the confusion matrix value. So these are the same. African and African, totally no confusion. Here also no confusion. So and let's apply the accuracy score also. Let's apply the title. Title will be convert the accuracy score into the string. Let's round it. What we got the accuracy score, ACC. Going to make it as percentage and take up to opposite it's 3 decimal places. That close that one and percentage. That's all. Now let's that plot the title. So let's make it h large. Dysentery accuracy score 92.58 percentage. Okay, now guys, I request you as a homework, I will share that code file. So as a homework, you will try apply the gradient boosted classifier and random forest classifier and try to save it in your system and try to find it what is the accuracy you got if you increased or not. Just try to play with it using different type of models. Okay, you can also change the parameter, you can, so such kind of thing you can do yourselves guys, because I have already made a huge large amount of video sorry, not large time large length video. Okay, it's near about 2.5 hours. So for that I am going to do that. So for for your for your as a home task for your better, so just take it as a yourself, so take it yourselves. Okay, so that's for today. So in next day we'll see some more interesting topic, more interesting. Okay, thanks for all.